Okay, so no booklets, so we're not expecting any hand-down skeleton notes. We're starting from fresh. So I was looking at your next booklet because we're going to talk about linear functions and quadratic functions. Continue on with that. But before we get into that, I want to make sure that we all understand where this line, these points are coming from. Okay, and that's a challenge for me because we can't just do that on a graphing calculator, right? Anyone here going out in the real world pulling out a graphing calculator? No, not really, right? So how do you do some stuff, some skills, without the calculator? So here it is. So the first that we're going to talk about is so this is the title, Slopes and Linear Functions. So starting with the slope, what comes into mind when you think about slopes? Skateboarding. Hill. Okay, let's write that down. Those are great stuff, right? Great stuff. So what do you think about so we think about snowboard. What did you say? Snowboarding, yeah, snowboarding. Skiing. Oh my gosh, all winter stuff. What? Mountain what? Oh, mountains. Okay, I thought you're mountains. Okay. Yes. What else? Roof. Roof. The roof of the house. Okay, roof. What else? Something that's, huh? A cliff? Okay.
Cliff or hill?
Oh, cliff or hill. Okay. Cliff or hill. Yeah. Yes, okay. There's probably lots. Sledding. I think that's a double D. I'll just put double D. Sledding. Have you been to the play structure lately?
Slides.
Slides, yeah. Slides.
Sand dunes.
Huh?
Sand dunes.
Sand dunes, okay. Sand dunes. Dunes. Waves? Yeah, but no. We'll preserve that for next grade 12. Yeah.
Another example is orthodox pitching, where you start at the bottom, you cue at a slope, and then it drops down. So it's called kind of like a horseshoe pitch, where you throw up and it just goes
Okay.
down.
Okay.
So it's one motion, so it goes
Okay.
up.
Okay.
It's still a constant slope.
Okay. So, tell me what's the name again?
Orthodox pitching.
Orthodox. Okay. Or I've never orthodox pitching.
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 PITC.
Okay, I've never heard of that. I don't know what that is. I gotta check that out.
I played baseball for 7 years.
Okay.
I started off slow pitching and orthodox.
Oh, okay, yeah, okay. Sure, okay, yeah. I'm not saying it's wrong, it's just I've never heard of it, so. Mm-hmm. A ditch? Yeah. How'd you get up here? Stairs? Yeah, stairs. No, that's not.
Window.
Stairs. Okay. It's funny how your mental image of slope is this. Okay, just by the way you describe these examples, like you probably have some kind of a mental image of what a slope is, right? So a slope would be either sloping like this, yes, or it could be, right? So slope, it's either increasing if you're climbing up the slope or you're coming down the slide. That's what your slope. So those are important. Those important mental image of what real life slopes are. Okay, that's awesome. So, well, what is the slope in math? What is the slope in math? Now, slope in math is a rate of change. Who's heard of a rate of change before? Who's heard of rate of change? Hmm? Huh? You use it in chemistry? How? How do you use it in chemistry? Yeah.
You know equilibrium, where you find the equilibrium is changing, sometimes rate is changing.
Okay.
Sometimes depend on the temperature, depend on the concentration.
Oh, okay. Good. Chemical reaction, yes. Yeah. And they use rate of change? Okay.
Chemical reactions are really
Yeah. Rate, how fast the reaction is, yeah. Good, good. Rate of change. So, a rate of change. So something is changing along the way, right? Something is changing along the way. So, a rate of change. How fast something is increasing or how fast something is decreasing. Okay? Now, rate. Okay, what does the word rate, what does it come, what comes into mind when you hear the word rate?
Value.
Speed. Okay, yes, thank you. Speed. Speed is a rate.
Movie rating?
Hmm?
Movie rating? As in you rate the movie?
Rating for movie. Oh, okay, that's okay. I'm gonna put that in a separate category because
what about money?
rating of movie. Okay, I'll just put it here because the word rating is there. Okay. Hmm? What do you mean money?
Rate.
More. I'm waiting.
I don't understand.
Like exchange.
I just think of money as like
Exchange rate. Is that what you're saying?
Yeah, exchange.
Oh, okay. Exchange rate. Yeah.
Like, yeah, Canadian US and US dollar.
Okay. Yeah. That's an exchange rate. Yeah. Okay. Yeah. Was that the one that you're talking about? The exchange rate? Oh, okay. Okay. Yeah. Exchange rate. What else?
What
That's a
about
good-
value?
Hmm?
Value.
Value of. So rate.
You know, value of something you purchase.
Come, okay. Explain it. I'm not. Okay. Oh, what is it? Value. Okay. Okay. Oh, I don't know. Maybe. You want to think about it first? Okay.
I think of a scale.
Exchange, right? Skill.
Interest rate.
Interest rate. Okay.
Effective value of the money, right?
Yeah.
Scale.
Scale.
Yeah.
Okay.
Can you rate something between 1 and 10? I think of like a scale.
Oh, you think about the some scale. Okay. Okay. Yeah. Oh, that's somewhere in this category. Rating a movie or scaling, right? Or scale. Okay. Good. Go like this. Or go like this. Oh, good. It's good, right? I could feel my heart rate. Okay. So those are all rate, and then when there's something, there's a change, rate of change. It's a slope. Have you heard? Yeah, speed, right? Let's write down the speed. How would you say the speed is? What's the speed measured on? Hour?
Miles per hour.
Well, miles per hour, that's US, okay. Kilometers, let's use Canadian. Kilometers per hour. Meters per second if you're taking a physics. Okay, well, fine, we'll just put miles per hour. Miles per hour. Okay. Exchange rate. How would you do exchange rate? I don't even know what the exchange rate is because I never exchange money.
You exchange
US
$1.
compared to $2.
Yeah, but okay. So we can say
$. Sign to.
Canadian dollars
Two.
per US dollars. Yes?
Yeah.
Okay, good. What about interest rate?
Do percent.
Percent per
Dollar.
percent
The year.
per
Annual.
year. Annual interest rate, right? Percent per year. Yes. Heart rate.
BPM.
B
Per minute.
PM. Okay, that's beats per minute. Okay. Do you notice something going on in here?
All of them have a slash.
All have a slash. Yeah. What else do you notice?
They all have counterpart.
Huh?
So they all have a counterpart.
Like a measurement.
The bill.
An X and a Y.
Oh, okay. There's a.
Or they have
Well, I don't know what X and Y's are. I don't know where that X and Y are coming from. Maybe it will come in later. So yeah, let's start with this one. There's all slashes. What does a slash mean?
Per.
Per. What does a per mean?
Five.
Divide.
unit with another unit.
Divide. Yeah, another unit divided by another unit. Okay, good. Very nice. So, here we go. Slope. I'll start with the slope formula.
Excuse me, I missed.
Okay, M is equals to y2 minus y1 over x2 minus x1. Okay, now that doesn't make sense to us, right? That doesn't make sense to us. But let's see if we could figure it out. Okay? So, I'm going to give you a context and let me know if this is something that you could relate with. Okay? Do you remember the candle? Remember that birthday candle? Okay, so I'm going to do another candle. Okay, here's a candle burning. And then I say, in 5 minutes, the length is I'll just make it up. 10 centimeters. It's not the same candle, obviously. So in 8 minutes, the length is 6 centimeters. Okay. So think about the candle. What's happening to the candle? It's lit. As time goes on, what's happening? It decreases. There's a change. There's a change in length, yes? But there's also a change in time. Yeah, time has changed, so has the length. So, this is what we did last time, yes? Time, height. So if you were here, you would remember this. Time is in minutes, and height is in centimeters. So let's put that in. 5 minutes, 10 centimeters. 8 minutes, 6 centimeters. Okay, so let's see if we could figure out a rate of some sort, and then we'll use that rate to make sense of what we're trying to figure out here, because I don't know where we're heading. Well, I know exactly where we're heading, but I want you to know where we're heading. Okay, so remember, this is our x, yes? And then height would be y, yes? Okay, so this is our first time, 5 minutes. We're gonna call this our x1. And then the height at 10 centimeter, that would be our first y1, first height y1. Okay, now we keep going, and then here, then time again, that would be our x2. And then what's the y? 6 would be our y2. Okay. So as you can see, it's decreasing as time. There's a change in the time, and there's a change in the height. We know that. So let's use that over here. Put these values into this equation. We know how to do this. We're going to follow the recipe. y2, what do I put in y2? 6. Okay, we put 6. Is everybody okay with that? y2 is 6, yes? Minus y1. What's y1? 10. Okay, y1, 10. Okay. Divided by x2 is 8, yes? Minus x1 is 5. Okay. Is everybody okay with this? Starting off with the formula. We don't know where we're heading, but let's see if that makes sense to us. Okay, let's perform this operation. 6 minus 10 minus 4, negative 4, yes? Divided by 8 minus 3. I do this all the time. 8 minus 5, I meant 3. Oops. 3. Okay. Yes? Everyone with me? Okay, well, what does that really mean? It means what? Okay, well, what's the y value again? Y is height, so negative 4 centimeters. And then what's the x again? The time in minutes. Interpret this for me. What does that mean? What does a negative 4 mean?
There's no candle anymore. It's
Okay, negative 4 means, what does a negative represent? It meant went down. It went down. Okay, so a negative 4, it means it went down, it got shorter, 4 centimeters. So it goes down 4 centimeters per 3 minutes. Is that okay? Does that make sense to us? The rate of change, it means that negative, it means the height goes down by how much? 4 centimeters every 3 minutes. Now, let's do this for a second. How would,
Flow is run.
huh?
What is minus flow? Run or raise?
I can't.
-4.
-4.
Is it run or raise?
Oh, I haven't even used that word before. Okay, I haven't used that rise over run before. Okay, let's not do that one right now. What would this be? Do this on your calculator, and you go -4 divided by 3.
Negative 12.
What would it be? Negative 1.33333333. Yes. Okay. Negative 1.33333. And what's the unit? Centimeters per minute. Well, what does that mean?
Every minute it's going down.
Every minute.
Yeah, it actually broken up into now, not per 3 minutes, but it's now going down by 1.333 per 1 minute. Okay, so this slope business has a meaning. It's the rate of the change. Okay, so far so good? Okay, good. I'm gonna try one more thing. Okay, here's another example. We're still in slope, okay? We're still in slope. Okay, remember that that guy who stole the fire truck?
Yeah.
Okay. Do you remember how fast the cop was running? He was running pretty fast, yes?
Yeah.
Okay. So here you go. So this is a fire truck, yes? Time. Okay. I'm just gonna make this up because I don't know how fast this person is going. I'll just make it up just for the fun of it. Okay. What does that mean? 0.5 means 30 minutes means half an hour. Half an hour later, okay, this person traveled 49 kilometers. I don't know. I'm just making it up. I don't know how fast this person is traveling, but we'll just. And then an hour and a half later, okay, an hour and a half later, it's traveled I'll just make it up.
Probably lower.
100.
I'm not sure if this is even gonna work, but we'll see.
Because 49 times 2 is 98. What's a quarter of that? Half of that.
Okay, so how fast is this person traveling? Okay. This is our X. This is our Y. Yes? So this one would be our X1. And this one is your Y1, right? This one is X2, second time. This one here is second distance, so Y2. So we're going to use the slope formula to figure this out. Okay. So let's go ahead and put those values in. What do I put for Y2? Y2 is 103 minus, what do I put for Y1? 49. Okay. What do I put for X2? 1.25, yes. Minus, what do I put for X1?
Why are you doing it backwards?
You think it's backwards?
Why don't you put Y1 first?
Because the formula.
Oh, that's an interesting one. That's interesting. Okay. We'll save that some other time. Okay. I'll show you that. I'll save it for another time. But that's a good question. Okay. So what would this be? 103 minus 49 is 54. 54 what?
Kilometer.
54 kilometers.
Okay, because remember y is distance, so that's in kilometers. Yes? And what would this be?
Hours.
0.75? Yeah, 0.75.
Oh, hours.
What did we start off?
Minutes.
Minutes?
Oh, hours.
It's hours.
Hours.
Yeah, 0.5 minutes. Oh, wow. Half a minute? Then it's supposed to be hours. Okay, interpret this for me. What does that tell you? What does that mean? Okay, what does this mean? We don't want to calculate something that we don't know about. So what does that mean? How do you interpret this?
Kilometers divided by 0.75 hours.
Right? So the truck is traveling 54 kilometers per 0.75 hours. Yes? That's how fast it's traveling. Now let's go ahead and do that. Divide it. Let's divide it. Okay. 54 divided by 0.75. 72. Okay. 72 what?
Kilometer per hour.
Kilometer per hour.
72
Kilometer per hour.
kilometers per hour. So how many hours is this?
1.
1. Okay. So we can say that the car or truck is traveling 54 kilometers per 3/4 of an hour, 0.75 hours. Or we can say in a different way, but same thing, that something is traveling 72 kilometers per hour. So this one means truck is running at 72 kilometers per hour. Maybe it's around 72, yeah. You can't be traveling 100. That's a disaster waiting to happen. How do you feel about slopes? How do you feel about slopes? You okay about it? Okay. Oh, sorry. Now, I'm gonna pause on the slope for now. I'm gonna talk about linear functions. Okay, linear functions. And let's see where this is gonna go from here. Honestly, I have no idea how far we're gonna go. We're just gonna roll with it. We're gonna go as slow as we can, as we want, as we need to, or as fast as we want to. Hopefully we'll go somewhere. Okay, done? I'll post it on the blog, don't worry. So now linear functions, Linear functions. So there's some kind of a relationship between two quantities that will create a linear relation, a linear function. So I'm just going to give you a random equation. We're going to start easy because, I mean, our graph paper here is not super big, so I'm not going to give you something crazy, okay? So let's see this one. We've seen this one before. Okay, this is a table of values. Y is equals to 2x plus 4. Okay. Do you recognize this from our last lesson? Yes, yeah, that's a linear regression. Linear regression, yes? So we said that, you know, on the calculator, we saw this. Yes? Yeah, okay, now, okay, let's see if we can piece those things together. Now, instead of ax plus b, I'm actually going to put no. Stop that. It's getting ahead of me. Getting ahead. Okay. This is what we're going to do. We're going to pick some x values in here. Okay? We're going to pick x values. We're not going to pick some crazy, weird numbers. We're going to pick nice numbers. So, I'm going to start with a -2, -1, 0, 1, 2, and 3. Okay, so we're going to pick -2, -1, 0, 1, 2, and 3. Good? So we already know, we've already identified the x. Can we figure out the y? Can we?
Yes.
Yes. Yes, we can. So how can we figure out? So if x is -2, if x is -2, we're going to put that in there. What is the y value?
0.
Okay. So you say 0. So y is equals to 2 times negative 2 plus 4. Okay, that's going to give us y equals 0. Everyone okay with that one? So what's the combination here? Negative, if x is negative 2, y is 0. What about this one? If y is negative, sorry, if x is negative 1. Negative 2 times negative 1 plus 4.
Y is 1.
2. 2 times negative 1 is negative 2 plus 4 is 2. So if x is negative 1, y is positive 2. Okay, let's do another one. What if x is 0? 2 times 0 plus 4.
Y is 4.
Y is 4. Oh, do you notice something?
Is counting by 2.
Hmm?
Counting by 2.
What's counting by 2?
Increasing by
What's increasing by 2?
The X
2. The y.
The y
The
value.
y value.
Yeah, so you're saying there's a change in here, yes? And how much change?
2.
Constantly changing by 2. Constantly changing by 2. So what do you expect this to be?
6.
6, okay. That's a good prediction.
8.
What's the next one?
8.
8.
10.
And then this one is
10.
10. Very good. So this is constantly increasing by 2. Yes. And what is this increasing by? So from negative 2 to negative 1 is 1. So it increased by 1. Increased by 1. Okay, good. Here's what we're gonna do. We're going to plot this on our graph paper. Let's see what kind of picture we're gonna get. Okay? That's why you got a graph paper. So we're gonna call this example 1. Graphing. Okay, remember the graphing? Negative 2, 0. So starting in the middle, where would negative 2, 0 be? We're just going to use a scale of 1 for each one. Yes, negative 2, 0. Negative 1, positive 2. So starting at the center, origin, you go left 1 and then go up 2. Zero, 4, 0,